Yes, coders, we're back with another episode of Conquering the JavaScript Interview with a high energy intro today. We're going to be shifting gears to explore yet another crucial array method, the flat method. So it's time to flatten out nested arrays and make our coding lives easier. But before we dive in, make sure to check out the description down below for a link to our community membership. For $25 a month, you get access to our front end and back end courses. Combine them suckers together, and you got yourself a 300 plus hour multi real project full stack development course if you're interested. I also have a zero to hero React course that takes you from the beginner to advanced, including state management libraries and everything in between. And you'll have access to our Discord as well, where you can get real-time supportive help on your coding journey and not get assailed like you might in the Reddit comment threads or in Stack Overflow posts. So if you have interest in that, as well as any other courses or updates that come out to our courses, you get them in your community membership with no additional charge to you. So if you have interest, check out the description down below for a link to that. Otherwise, like I said, let's shape up the arrays and dive in the world of flat. So a brief history of it, it was introduced in ECMAScript 2019, which is ES10, I think. I've lost track of how this nomenclature actually works. I feel like I have to Google any method and when it was made, and I still don't know when it was made in the comments of like MD and WebDocs or something like that. So I have to like look at the specifications and sometimes do like tons of Googling till I find an actual answer for when something was introduced with a clear time. But nevertheless, it's relatively newer, and it had a need because as JavaScript grew in complexity, especially in the world of data-driven web applications, developers encountered tons of nested arrays of data, typically from API responses, complex computations, or multi-dimensional data structures like matrices if you have a stronger math background. So that need for a built-in standardized way to flatten them became increasingly evident, because beforehand, we'd all write them ourselves or do some, this is what I did, some kind of weird concatenated version of reduce and concats to flatten arrays, which would vary in efficiency and readability and makes for a great interview style question. So that need was there, and the gap was filled by standardizing this flat method, simplifying array manipulation, giving us better performance, less error prone code because it's all provided for us, and it got some pretty wide adoption pretty quickly. As a matter of fact, you're going to be seeing me use this and yesterday's video in tomorrow's video in our flat map advanced question. So something that is particularly difficult to answer on its own is broken down into this and yesterday's video to make it a lot easier. So if yesterday, as in if you're watching this asynchronously, yesterday for me was when I made the map video in this playlist, which you can find in the description down below as well. A link to the playlist rather, and you can find the previous video in the series. This video and the next video are all kind of intrinsically linked, so check that out if you haven't noticed that pattern already. So like I said, we're going to be implementing our own version of the flat method, which has a single purpose is to flatten nested arrays into a single level or otherwise specified array. We'll talk about that in a minute. The input is simple. It's going to be an array with varying levels of nested arrays. And the output, very straightforward, is going to be a single level array comprising all elements from the nested arrays. So the reason I keep putting that in air quotes, talking about its purpose and its output, is depending on how deep we want it to go, aka our depth. Now, if we don't specify a depth, it will flatten it out to single elements. But if we want it to go further, we can specify a depth level to tell it how deep into the nested structure we want it to go. So that's what that depth value is going to indicate to us. Not the output, but rather how deep do we want to keep digging into our nested data structures? Because there might be arrays of arrays of arrays, and you want to get rid of the third array part and only be left with an array of arrays, kind of like a matrix. So there are plenty of use cases for going to certain depth levels. So as an analogy, here's how we're going to think of this particular solution. Our task is taking a cluttered bookshelf, our input array. So our books, the elements of the array, are going to be haphazardly stacked and collected within boxes, which are our nested arrays. And some boxes are going to be inside of bigger boxes. So we can open a box, it's got some books inside of it. It might have another smaller box with more books inside of that are organized in some weird way. So that is going to be the nested structure we're thinking of. So remember, we have a bunch of random books all over the place, some in boxes, some inside of boxes that are inside of other boxes. That's our nested input structure. Our job is going to be to remove all the books from the boxes and arrange them neatly on a single shelf, which is our return output array. We're going to be carefully opening each box, and this is where it's going to be kind of key now. If we open a box and we see another box, that depth parameter that we're seeing in the window over there tells us, do we open that next level box and the next level box and the next level box? Do we keep digging inside of boxes until we hit the end and then work our way back up? That's what that depth is going to be telling us to do. So we're going to open that too until all of our books are laid out on the shelf. So clearly some recursion is going to have to happen. That is how we traverse our nested structures until we get to our chosen depth level. So I'm going to be showing you more than one way to implement this, including as in, it'll be fairly straightforward. I'll show you two different ways you can approach it. So what I'm trying to say is, like, we're going to have a simple, clean-looking way and then a bit more of a preferred method, I guess you could call it. That's a weird way to say it. I don't think it's preferred, but it's going to be a little bit different. So I'll code it two ways to show how it goes. As always, modifying the prototype of the array object is not a good idea in real-world projects, because if we're not documenting it or we're using libraries and things like that, the chances of us messing it up, messing somebody else up, or messing a library up is very high. So this is not advice to do on real-world projects, but for educational purposes and interview purposes, it showcases that you have a good understanding of prototypical inheritance and you have a strong understanding of the JavaScript fundamentals, which means that you know what you're doing. So again, being able to write this out and even give those arguments for against using it in a real world and why you're using it in an interview is a great thing to know how to answer. Okay, so this is a non-mutating method, meaning it's not going to mutate our input array in any way, which is a pretty good indicator that we need to return some kind of array. Remember, if you don't have that return keyword, your interviewers could ding you, so it's always a good idea to get used to writing it if you need to return something, for example, if it's a non-mutating method. Again, if you're not in a code editor or an IDE during an interview, you're not going to get that kind of undefined console log letting you know you forgot something. You're just going to get dinged by your interviewer because you forgot it. So always good to put it in there. Now, like I had said, this thing takes an array. It's called on an array, which is what the keyword this will represent inside of this code. So the keyword this represents the thing furthest to the left for context, aka the array we call .custom_flat on. The other parameter was our depth level, which will default to a value of 1, not the string 1. My bad, that's a typo. The number value 1 will be our depth, aka how deep in the nested structure do we want to flatten. This is not corresponding like I initially thought when I was starting to work with flat and try to implement my own version. In my head, my brain kept telling me depth is how you want your output array to look, but the depth is how far you want to go in to the flattening process. Meaning, if we're looking at some of these input values here with the crazy amount of array square brackets, it's how far in we want to go. Because we notice a depth of 2 here means we remove 2 layers, we open 2 potential boxes of arrays, which is why we get these 2 sub brackets gone, and we get 1, 2, 3 as the output, but that inner array is 4, 5, and that's fine. If I specify this depth of 3, it'd be an array of 1, 2, 3, 4, and 5, all in a single entry. So again, the depth corresponds to how deep do we want to flatten, not what is how many layers are we allowing in our output. So that's the big difference that I want y'all to keep in mind, because it took me a while to tell my brain that's how it works. Now, rather than using an IIFE, which is what I would normally do, we're going to instead write it out as a custom function, because the recursion part's going to have to happen here regardless. I don't want to make a utility function outside of custom flat, because that would pollute the global namespace. And if I forget to copy over this utility function, we're going to call it flatten. If I have this out of scope of my custom flat method, that means I'll have to remember to copy it over along with any code I intend to use it with. But if I keep it inside of the custom flat method, it now is simply scoped into custom flat and available inside of there only, and it's not in the global namespace that I could potentially forget it if I needed to carry over my custom flat code somewhere else, which is why I'm going to choose to write it inside of here. And as you guessed, we're probably going to have to also do the following. We're actually going to have it call itself like this. Its purpose is going to be looping through our elements. It will then need, loop through elements. If element is an array and depth is more than 0, then we flatten again. Otherwise, else we push element into result. There's our pseudocode, and where you can see the recursiveness in action. So the purpose of flatten is going to be looping through the elements we're currently looking at. if the element we are currently looking at is an array and our depth is greater than 0, then we're going to call flatten at the next depth level. Otherwise, if our depth is equal to or less than 0, and the element is not another array, so it's just like a number or a book and not another box, we put that book into our new single level bookshelf. That's what's going to happen here. So this is the recursive part. This is what the thing's actually going to do when it's flattening. So clearly, flatten's going to have to call itself, and it's going to require 2 arguments to get the job done. The array we are currently looking at, because remember, this could be an element that is another set of sub-arrays. Like when we call flatten here, so if the element is an array and we still have more depth that we are allowing ourselves to go into our nested box structure, then we got to keep on calling flatten with each array we keep, or each box we keep encountering. The next argument would be a parameter called depth. Now, the tricky part here is, if you're familiar with how local scoping works, I think maybe even lexical scoping or lexical environments is the term I'm looking for. Luke, you should have done your research before you used that term and said it completely incorrectly. I'm sure I'll be wrong. I'll look in the comments. Someone always lets me know. The point is, in the scoping of the local flatten function, it will have its own parameter called depth that I can specify and use. It will be separate from the outer function's depth parameter, right? So it'll be properly scoped locally inside of here, but we're going to be safe or safer and give it a variable name like current depth, which is like what we're currently looking at. So that's what we're going to be doing here. So we're going to pass in the array itself on our first call to flatten. So remember, this is what I talked about earlier. It's going to be the array we're calling this on. And then all we're going to do is take this depth parameter and daisy chain it on down into our flatten function like that. So our current depth is going to be, hey, how far down are we allowed to go down in our nested box structure? So looping through the elements is easy enough. We're going to simply do a for loop. We don't really need to know about index positions in this case, so I'm going to save myself the headache of, again, if we're at a whiteboard with an expo marker, or we're in Notepad, or if you're on a sheet of paper in an interview, there's other things I'll probably want to talk about to my interviewer, but if you are in an environment where you don't have autocomplete and IntelliSense, red underlines, and things like that, then I do advise that you use any shorthand you can, like this. Let element, or for of array, right? So for element of array. Take the array we're currently trying to flatten and loop through it. For each element of the array we're looking at, we need to determine, as my comments show, if it is an array and our depth allows us to go further. Otherwise, open the next box. Otherwise, just push it into the resulting array. So let's go ahead and write the easy part, which is our if-else structure, right? That goes up in here. And that goes up in the else block. The else block is very simple. Simply push into our resulting array the element, because either we're not opening the box because our depth doesn't allow us to, or there is no box to open and our element is a book, so we just put it on our new bookshelf, which is our resulting bookshelf. Otherwise, we have to open the next box and flatten it. Here's what we do. So remember, if we're flattening another box, we're opening another box, then we're passing in the element, which is a box that we are going to be opening, right? So another array. And we're going to pass in a depth level of what our current value is, -1. Otherwise, this will go forever if we're not careful. So remember, we have a specified depth level that we're allowing ourselves. In the default case, it's 1, so it'll only go down 1 level ever, which, again, we can see in the first input over here. Right, we have a 2-level array, but we flatten it out only 1 time. We do not go into the sub array, that sub box of 5, 6. We don't flatten that part out with a depth of 1, because once it gets to depth 0, then this if statement won't matter, and we're not going to be opening any second-level boxes, only first-level boxes. Otherwise, we push that into our resulting bookshelf. So this opens any inner boxes. This represents a box to open, and this represents how many layers of depth we are currently allowing. Okay, so that's the recursion process. It's got to end somewhere. Either we run out of array elements, other arrays or other boxes, or our depth level says, hey, we stop here, we're not flattening any further. So we're going to be using another array method, you guessed it, off the array object, the isArray method that will tell us whether the element we are looking at is an array or not. Is it a box or is it a book? If it's a box and we have some depth to work with, Then we flatten and go one level deeper and subtract 1 from our current depth. And we recursively call flatten. Otherwise, we take the box or the book, depending on our depth level, and just simply add it to our shelf, and that is it. So we initiate our method. We declare our result, which is our bookshelf, where all of our books are going to be put on a fresh shelf, and we go through the recursion core, right? Our function flatten will loop through the array. For each element of the array, it's going to check to see if it's a nested array or not, or if we are not at our desired depth or not yet. If we aren't, then we go deeper. We're going to recursively call flatten on the nested array, including a depth -1. If we have reached our limit or the resulting element is not a subarray, we simply push it onto our new bookshelf. And then this is the initial call, by the way, of flatten. Don't get confused. This is not the recursion part. This is the initial call of our flatten function. Then we simply return our result, and we should be good to go. It should contain all of our books in a flattened format. So let's go ahead and grab these examples here and go through them. We're going to have const r. Is this subarray mess going on here? We'll have a depth value of 1, like our output, I believe, has. Or our depth requirement is here. And we're going to see if this output matches here. So hopefully it does. We are going to console log our array. Flat, no call, because our depth is going to be 1. We're going to test it to see if it works here. Let's see if it works. 1, 2, 3, 4, subarray 5, 6, because it only unpacked 1 depth level. So it succeeded in its job. And if I pass in depth as the parameter, let's make sure it doesn't change or break anything. Always good to test. Our default parameter works for 1, is totally fine. Let's grab our next one, which is a depth of 2. Let's grab this input array. We're going to paste. I should do this up top or something because it's kind of annoying having to scroll up and down. But c'est la vie. We're going to see if that matches the comment that we're expecting here. Boop, save. Oh, I didn't change the depth. I was like, well, that's not right, because I forgot to change the depth to 2 over there. Ah, there we go. So 1, 2, 3, subarray 4, 5. So again, a depth level of 2 meant this was the first box it encountered, and it unpacked it. That's a depth -1, so we have 1 left to work with. The next thing it found was another subarray, aka another box. But our current depth by this point is 1, which means we still have depth to go. So it was allowed to continue. By the time it gets to this level, it's still an array, so this test passes. But our current depth is 0 because it went from 2 -1 to 1 -1 to 0. So it's not greater than 0, it is 0, which means, hey, we're not flattening anymore, hence why that 4, 5 array is right there instead of the element itself. So the recursion process tells us how far in that depth level we can go. If I take this to a 3, it should be the whole thing as a completely flat array. That should be the result on a depth level of 3 because it says, hey, we still have depth to go, so unpack that and put those books on the bookshelf, which is what it does. And I think I'm willing to guess that my final example does that. Yeah, infinity, Luke. Good one, man. If I put that in there, let's see what our output's going to be. I can't do infinity. Hold on. Yeah, let's see if I do a depth of 3, it should, just cram it all into one single array right there. So there you go. That's fun. That's our implementation there. And I think on the global object, I think there is an infinity. No, there is an infinity. I knew that. Who said I didn't? There is an infinity. Does this work? It works. Okay. So we have an infinite depth and it still worked there. So it did the job pretty dang well. I forgot the infinity is actually on the global object. It's a numeric value that represents infinity according to the MDN web docs. I was like, I figured it'd be like a math.infint or infinity or something like that, but I didn't realize it's just a property of the global object. The more you know. Today I learned. Look at that. I'm learning along with you guys in these videos, which is why I like making them. Okay. That about rounds it out for our flatten function. I did say there's going to be a second way of solving it that I think looks a bit cleaner because, as you can see, this first call of flatten down here can sometimes confuse students, but there's an easy way to get around this. Like, you might find this easy to write this way. I personally like doing the following. I'm going to wrap my function in a set of parentheses. I'm going to leave the function name and params there for now. I don't really care. I'm going to remove this keyword flatten down yonder and simply move those parentheses right on the outside edge of the other set of parentheses. So now I have an IIFE structure, aka an immediately invoked function expression. I still want to give it a name because I do have to recursively call it in here. I just think the recursion, if I'm going to be using this recursive solution and this function here, that initial call kind of uggo. So I remove it down to typically just this IIFE structure right here, as you can see, right? So yeah, my cat Percival is like right on my side monitor over here looking at me all weird. So if you keep seeing me look at something, it's my cat giving me this criminally offensive side eye right off the camera because he knows where to be to like distract me, but not actually be on camera. So yeah. The IIFE solution is a little bit cleaner, and again, it shows that you know what you're doing and you have a strong command and mastery over it. I mean, other than the recursive part, there's no reason to give this function a name just for the recursive part here. So we save ourselves that function call by just doing an IIFE, remember, immediately invoke function expression syntax instead, and it should result. Yeah, it should result in the same thing. I hit save to redo the output to make sure it didn't affect anything. So it's a little bit cleaner. So that's why I was like hesitant on defining it as better or different implementation, because it's really not. It's just a little bit more concise and competent, I would say, right? So yeah, that about rounds it out for this video and this implementation. Again, the code pen will be in the description down below, along with that community membership, should you be interested. If you found this enlightening, give us a thumbs up by clicking that like button down below. Subscribe for more deep dives in JavaScript, random projects that we build on this channel, random lessons and tutorials, and previews of course videos that I make that I just put on YouTube for free, because I like to keep as much, all the content I make for our courses I put out here for free anyway, or at least I try to. So if you have any thoughts or questions, drop a comment down below, and stay tuned for our next video. Our next episode in this series will be combining this video, the previous video, into one video called the flat map. So keep on flattening those arrays, and happy coding until we meet again.